In this problem, we're asked to use the integral test to determine convergence or divergence. Given the series sum as k equals 3 to infinity k times e to the negative 5k squared. Okay, so we're given that we need to use the integral test, so let's go ahead and set that up. Remember that you cannot set an integral with infinity as one of its limits. You can write it down briefly, but you need to make sure that you do this correctly. So what we're looking at is this, the integral from 3 to infinity of x e to the negative 5x squared dx. Okay, now we want to change that to the limit as b approaches infinity of the integral from 3 to b of x e to the negative 5x squared dx. Okay, so that's how to write it from an improper to a proper integral using limits. All right, so in order to solve this integral, you may notice that this e has the exponent, and when you recall that when you have a natural exponential, if you can get it in the form e to the u, then the antiderivative is still e to the u, so that'll be a pretty easy integral to solve. So let's try to sub in and make this exponent just u. So if we make that u is equal to negative 5x squared, then du will be equal to, bring down the 2, so that's negative 10x dx, which means that dx is equal to negative du over 10x. Okay, now we can also change our limits on this. So remember, if x is equal to 3, then u is equal to what? We got to do the substitution, so plug in a 3 there. So if we plugged in a 3 there, we get 9 times negative 5 is 45, negative 45. Okay, and then for the other one, if x is equal to b, remember we changed it to b, then u is equal to negative 5b squared. Okay, so those are now our limits, so we're going to rewrite this as the limit as b approaches infinity, the integral from negative 45 to negative 5b squared. Okay, now we'll rewrite it in terms of u. So this, we made this the u. Okay, the x is still there. So x e to the u, and dx we said was negative du over 10x. Okay, so negative du over 10x. Okay, now the x on top and the x in the denominator will cancel, and then the negative 1/10 can be put out front. Okay, so we get a limit as b approaches infinity of negative 1/10, negative 45 to negative 5b squared of e to the u du. So we do have it in the form that we want, which means that we can just write down the answer because the answer is e to the u. Don't forget your negative 1/10. So we get the limit as b approaches infinity of negative 1/10, and then we have e to the u evaluated from negative 45 to negative 5b squared. Okay, so let's do that. Evaluate that limit. Here's my negative 1/10 on the outside, and on the inside I'll have e to the negative 5b squared, and then minus the lower limit, which is e to the negative 45. Okay, so what happens when I send b to infinity? Okay, well, what happens to this exponent? Your first thought might be, well, it goes to infinity. Well, actually, it goes to negative infinity, right? Because we have a negative sign here. So what happens as I send the exponent of e to negative infinity? Well, I'll write it over here. As e gets large, let's say negative 1,000. Okay, can't really see that. Let me change color. E to the negative 1,000. Okay, that's 1 over e to the 1,000. Okay, so it's going to be a big, big number, but it's going to be in the denominator. And if you have a big, big number in the denominator and the top is constant, then you are headed towards 0. Okay, so as b gets larger and larger and larger, this term gets closer and closer and closer to 0, so it goes away. Okay, so that leaves all numbers. We have no more variables, so we don't even need the limit anymore. This is just going to be negative 1/10 times negative e to the negative 45. Let's clean that up. The negatives can cancel each other out, so that gives us e to the negative 45 divided by 10. And you can leave it like that. That's perfectly fine. Or you can write it as 1 over 10 e to the negative 40, or to the, not to the negative 45, to the 45. Let me write that again. 1 over 10 e to the 45. So it does converge, and that's what it converges to.